This is CAE paper, May, June 2007, S1. So we shall start to solve all the questions. Let us start from the first question. So comes about coding. This question comes from the concept coding. So we have to make two columns anytime, original and coded. Over here, he gives sigma t minus 35 is equal to negative 15, sigma t minus 35 whole square is equal to 82.23, and n is equal to 12. So he's asking calculate the mean and the standard deviation. So what am I going to do? I am going to find the coded mean. Coded mean is sigma t minus 35 divided by n, so which is negative 15 divided by 12. Now I want the original mean. So original mean, in order to get back to the original mean, the coding was done as minus 35. So I will add plus 35. So to get the original mean, what am I going to do? I'm adding plus 35. So when I do this one, directly I'm writing the answer 33.75 minutes. Don't forget to write the units. Next is asking us to find the standard deviation. So standard deviation, we know that in original and coding, standard deviation doesn't changes. So standard deviation remains the same, sigma t minus 35 whole square upon n minus coded mean whole square. Remember, it should be coded mean whole square. So which is square root of 82.23 divided by 12 minus 15 upon 12 whole square. Simplify that, you get 2.3 minutes. That's the answer for the first question. Coming to the second question. Jamie is equally likely to attend or not to attend a training session before a football match. So attend, not attend. So 0.5 is attend, 0.5 is not attend. Attend. Attend and not attend. If he attends, he is certain to be chosen for the team which he plays for the match. If he is attending, then he will be certain to chosen. Chosen is 1. Not chosen will be 0 because he is certain to be chosen. Then if he does not attend, there is a probability that 0.6 is chosen for the match. So if at all is not attending, then chosen for the match is 0.6. 0.6. So not chosen will be 0.4. Not chosen. Find the probability that he is chosen for the team. So what are the probabilities that he is chosen for the team? This one and over here. So probability of being chosen should be equal to 0.5 times 1 plus 0.5 times 0.6, which becomes 0.8. That's going to be the answer. Okay, so coming to the next part. Find the conditional probability that Jamie attended the training given that he was chosen for the team. Given that he was chosen for the team. Remember, whenever given that is there, so that write in the denominator. Given that he was chosen for the team. Chosen for the team. So chosen for the team was 0.5 times 1 plus 0.5 times 0.6. A part of it goes to the numerator. Which part? So that will be there in the question. He is asking probability that he attended the training session. Attended the training session is 0.5. So attended. So that goes to the numerator. So 0.5 times 1. So when I simplify this, I get 0.625. 3 significant figures. Third question, the random variable x is normally distributed. The mean is twice the standard deviation. Mean is equal to 2 times the standard deviation. It is given that probability of x greater than 5.2 is equal to 0.9. So convert x into z greater than 5.2 minus mu by sigma is equal to 0.9. So if at all I want to convert greater to lesser than, 1 minus probability of z less than 5.2 minus mu by sigma is equal to 0.9. Then bring this one, so the other side, 5.2 minus mu upon sigma is equal to 1 minus 0.9. Probability of z less than 5.2 minus mu upon sigma is equal to 0.1. But I see that 0.1 is not present in the table. Not in table. So what am I going to do? I am going to do 1 minus, so it becomes 0.9. To nullify that effect, this 5.2 minus mu can be written as mu minus 5.2 over sigma. So check that 0.1 will not be there in the table. So in order to convert into 1 minus 0.9, so to nullify that effect, 5 minus 5.2 minus mu can be written as mu minus 5.2. Now check from the table, mu value is 2 sigma minus 5.2 divided by sigma. This from the table gives me 1.282. So from there, 2 sigma minus 5.2 is equal to 1.282 sigma. So 2 sigma plus 1.282 sigma is equal to 5.2. Then let me add a page over there. So it becomes 3.282 sigma is equal to 5.2. Sigma is equal to 5.2 divided by 3.282. Then I get the value of sigma as 7.24. That's going to be the answer. Anything else is asked? That's the first part. Second part, a normal distribution has a mean mu and standard deviations 8 sigma. 800 observations are taken from the distribution. How many would you expect that it between mu minus sigma to mu plus sigma? Mu minus sigma to mu plus sigma. Probability of mu minus sigma is less than x less than mu plus sigma. So what am I going to do? So every time second one minus the first one less than mu minus sigma. Convert mu in x into z, z minus x minus mu, mu plus sigma minus mu upon sigma, then mu minus sigma minus mu upon sigma. So but z less than mu minus sigma minus mu upon sigma. So this becomes probability of z less than 1 minus probability of z less than minus 1. So probability of z less than 1 minus 1 minus probability of z less than 1. So it becomes 2 times of probability of z less than 1 minus 1. So check from the calculator or from the table. So finally I'm going to write this one as the value from the table. Let me quickly pull that one. 0.8413, I think so. 826, okay, 0.8413 times 2 minus 1. This becomes 0.86826. That's going to be the answer. But this is only for 1. But I want for 100. So therefore, 0.6826 times 800. So this will be approximately 546. Because there are 800 observations. When you scroll up and see, there are 800 observations. For one observation, it was 0.6826, but for 800 observations, it is times 800. Question number 4. Draw a back-to-back stem and leaf. So I can see the what is this? It is 9-year-olds and 16-year-olds. So minutes to swim a certain distance by the members of class 12. 12 9-year-old students and 8 16-year-old students. So I have to draw a stem and leaf. So first of all I have to make a stem. So let me make a stem. This is a stem, and I see the numbers are between the least number I can see that it is 11, and the highest number is 16. So I can do 11, 12, 13, 14, 15, 16. Then I make 2 columns for 9-year-olds. So 9-year-olds 13.0. I done 16.1, done 16.0, done, then 14.4 done, 15.9 done, 15.1 done, 14.2 done, 13.7 done, 16.7 done, and 16.4, then 15.0 and 13.2. So as you write on, keep on striking it off like that, okay, so that you don't miss anything. And there are how many 12 should be there. So have I got 12 or not? Check it out. This is 3, this is 2, this is 3, and this is 4. 7, 10, 12. Yes. But you should not leave it over here. You should write in an order. So 0 to 7. So what can I do with this? What is this? Bring 2 over here and 7 over there. So I'm bringing, I need to arrange them in order. 2, 7, 2, 4 also. I need to arrange to bring 2 and 4. So you need to write it out in an order. So you can erase and write. So 0, 1. So this is easier one. So what I can do is erase this one and write as 0 and 9. And this is 1, 4, 1, 0, 7, 4. So 1, 0, 1, 7, 4. So 0, 1, 7, 4. It becomes 0, 1, 7, 4, 7. So those are the case. Similarly, now you have to do for the 16 years old. 16 years old, then the least 14.8, 13.0, 11.4, 11.7, then 16.5, 13.7, 12.8, 12.9. That's all. These are the answers. Check it out. 2, 1, or 2, 2, 1, and 1. So there should be how many people over there? 8 people. Do I have 8? 6, 8. Yes. Then don't forget to write key. I take randomly any number. So 14/2/8 means 14.8 minutes and 14.2 minutes. Write the key. Now a new people of 16-year-old class join the 16-year close down and swam the distance. The mean time for the class of the 9 peoples is now is 15.6. Find the new people's time. So 16-year-old, right? So 16-year-old, a new person has joined. So what am I going to do? Take the numbers for the 16-year-old. So what is that? The numbers for 16-year-old? 14.8 plus 13.0 plus 11.4 plus 11.7 plus 16.5 plus 13.7 plus 12.8 plus 12.7. This all has been added up. So to find the mean, what am I going to do? And we need to add up all these things and the new person, let it be x, divided by how many people are there? There are now 9 people, and its mean is 15.6. Is it 15.6 or 13.6? Let me erase over here and check. It's 13.6. So got this one and write 13.6. So when I add all this, it becomes 106.8 plus x should be equal to 13.6 times 9. So x is equal to 13.6 times 9, which is 122.4 minus 106.8. So this is 15.6 minutes. Question number 5. Find the number of ways in which all the 12 letters of the word refrigerator can be arranged if there are no restrictions. Refrigerator. How many alphabets are there? 12 alphabets. So 12 alphabets can be arranged in how many ways? 12 factorial ways. Divided by, are there any repetitions? 1e, 2e, 2 e's are there, so 2 factorial. Is there any another alphabet to be repeated? R, 1 R, 2 R's, 3 R's, 4 R's, so 4 factorial. Divide by the repetitions. So directly I'm writing the answer. That's the answer. Whatever the number of the alphabets are repeated, so that divide by that. If all R's must be together. The second part, all R's must be together. So therefore 12 alphabets are there. So what do I have? 12 units. 12 units. Subtract those 4 units and add all those r's as one bundle, so 1 unit. So it becomes 9 units. This 9 units can be arranged in how many ways? 9 factorial divided by, in that, what is this case is this 2e's will become 2 factorial divided by 2 factorial. Now no need for r. Why no need for r? Because this 4 r's can be arranged in 4 factorial, because they are all same, divide by 4 factorial, they get cancelled, so no need to write that one. So my final answer will be 181440. How many different selections of 4 alphabets, 4 letters from the 12 letters can be done? Contains no r's and 2 e's. No r's and 2 e's. So okay, third part. So I need to select 4. Total I need to select 4 from the word refrigerator. Refrigerator. There should be no r's. So what I will do, first I'll make a space because the space is not sufficient. So let me make a space for this. Oh, no need to make a space. So what I do is I better add a page. So I need to have the word refrigerator. Let me write the word refrigerator. I need to select 4. There should be no r's. So contains, he says, no r's but contains 2 e's. So cancel of r, and r. And 2 e's. This e and e, move them there. So I need to move this e over here. I need to move this e over here. So basically there are 4, right? 1, 2, 3, 4. Move this e over here. So what am I left over with? Move this e over here. So I have left over with 2 more places. I'm left over with 2 more places. 1, 2. And how many alphabets I'm left over with? We will be counting it out. It's 1, 2, 3, 4, 5, 6. So 6 alphabets. And how many places? 2 places. So I need to choose. So it can be done as selection. 6C2. Answer is 15. Question number 6. The probability that New Year's Day is on Saturday in a randomly chosen year is 1 upon 7. 15 years are chosen at random. Find the probability that at least 3 years. So probability of success is 1 upon 7. Probability of failure is 6 upon 7. So n is equal to 15. That at least 3 years. So means probability of x greater than or equal to 3. Means it is 3, 4, 5 and so on till 15, which is very large to add it out. So 1 minus 0, 1 and 2. That will be easy. So 1 minus 0. 15 times 0 times 1 upon 7 is 0. 6 upon 7 is 15. Then 1 times success. 15C1. 1 upon 7 to the power of 1. 6 upon 7 to the power of 14. 15C2. 1 upon 7 to the power of 2. 6 upon 7 whole to the power of 13. Simplify this, 0.365. 56 years are chosen at random. N is 56. Use suitable approximation. Whenever n is large, we need to use approximation. That more than 7 years have this New Year's Day on a Saturday. So I have n is equal to 56. So find mu. Mu is np. N is 56. Probability of success is 1 upon 7, which is 8. Sigma square is equal to npq. 56 times 1 upon 7 times 6 upon 7, which becomes 6.857. He's telling it is probability is greater than 7. So which is probability of z greater than 7 means 7.5. Greater than 7 will be 7.5 minus mean is 8. By standard deviation is square root of 6.857. So probability of z greater than minus 0.5 by square root of 6.857. So 1 minus probability of z less than 0.5 by is 0.6857. 6.857. So rather than I'll write down this value is 1.9 0.1909 negative. Now in order to convert negative to positive, what should I do? One more time, 1 minus probability of z minus 0.1909. So it becomes probability of z less than 0.1909, which value gives me from the table as 0.576. So what I have done over there, converted greater to lesser than. So the procedure is 1 minus. Next time what I have done, converted negative to positive. So again what should I do? 1 minus. So whenever it is negative to positive also I should be doing 1 minus, and just check the table, you should be getting the answer. Question number 7. A vegetable basket consists of 12 peppers. Peppers how many? 12. Of which 3 are red, 4 are green 4 and yellow are 5. Okay. So what I can do is I write in that colors only. Red are 3, green are 4 and yellow is 5. 3 peppers are to be taken at random without replacement. The question is without replacement. Find the probability that 3 peppers are all of 3 different colors. So I can take one from red, and I can take one from green, and I can take one from yellow, divided by 12C3 because it is probability. So 3C1 times 4C1. So this is for red, this is for green, and this is for yellow. Next, show that the probability of exactly 2 peppers taken are green is 12 upon 55. 2 should be exactly green. 2 should be green. So I have 4 greens out of 4, 2 greens. So remaining I have to take 1. 1 more I have to take. So how many are there from remaining? So it is 8. 5 plus 3. So 8C1 divided by 12C3. When you simplify, it becomes 12 upon 55. So this 8 is from the remaining, which is a combination of 3 red plus 5 yellow. Next one, the number of green peppers taken is denoted by random variable x. Draw the probability distribution for x. So number of green peppers. So how many green peppers are there? We shall check it out. How many green are there? 4 green are there. And how many am I choosing every time? I'm choosing only 3. So I can get 0 green, no greens at all. I can get 1 green, I can get 2 greens, or I can get 3 greens. I cannot get 4 greens because I'm choosing only 3 peppers. So this is small x. Probability of capital X is equal to small x. Just now we have done that 2 greens is 12 upon 55. So we can write 12 upon 55. And that's it. Now 0 green. 0 green is very simple. So we'll go for 0 green. 0 green means all are from the remaining. So what are all? So 8 are there. So 8C3 upon 12C3. So you can write that value 14 upon 55. Then 3 greens is much more easier. Then I go for 3 greens. So all 3 are green. So from 4C3 upon 12C3. Because all 4 are greens. 3C3 for 4C3 upon 12C3. So which will become 1 upon 55. Now I want to know the remaining part. So what can I do? 1 minus 14 upon 55 minus 12 upon 55 minus 1 upon 55, which becomes 26, 27, 28. 28 upon 55. 28 upon 55. So that's going to be the answer for the question. That completes all the 7 questions of May June 2007 S1 paper. See you in the next paper.